guys, welcome to my channel Companion Chemistry. So I have chosen the topic General Organic Chemistry. As you know that we can divide the subject into three parts: physical, inorganic and organic. Okay, so I have chosen the organic part first. It's not like that I'll not make videos on physical and inorganic, but my own personal favorite is organic, so that is why I have chosen organic first. So we will start with general organic chemistry. It's a very vital chapter, and always remember that organic is very scoring if you know the concepts. Okay, so let us begin. Before starting, we will know that what is actually organic compounds. Organic compounds are very essential for sustaining life on earth. Why is it so? Because we human beings, the food we eat, the cloth we wear, all are made up of organic compounds. So that is why organic compounds are very much important for our livelihood. As you can see that I have written as carbon atomic number 6 and electronic configuration is 1s2, 2s2, 2px1, 2py1 and 2pz0. Okay, so from this we can understand that carbon has 4 electrons in its outermost shell, right? So either the carbon can have +4 oxidation state or -4 oxidation state. But we see that to form +4 or -4, carbon needs a lot of energy. So that is why a very less amount of ionic compounds are possible for carbon. So what does carbon do? Carbon in return share its 4 electrons, which are present in 2s2, 2px1 and 2py1. So that is why it forms covalent compounds. As carbon shares 4 electrons from its outermost shell, that is why carbon is a tetravalent compound. Carbon has a unique property of catenation. So what is catenation? Catenation is the power of carbon to form bonds within itself. Most of the carbon-carbon bonds are very much stable with a bond energy of 335 kJ per mole. Now we will discuss about a very important topic of hybridization of carbons. As you can see that the first type of hybridization is sp3. Here in the ground state there are 2 electrons in the sp orbital and 2 electrons in the 2p orbital. But in the excited state there are electrons 1 each in 2s and 2p. So we can see that in the excited state 1s and 3p orbitals are involved. So this kind of hybridization is called sp3 hybridization. Now we will see some kind of bonding in which includes sp3 hybridization. Drawn 4. This I have drawn 4 orbitals of carbon. Now in the same manner I will draw another carbon of 4 orbitals. In between there is a junction, which means there is an overlap, that is C single bond C. Similarly, in the remaining 3 orbitals we can have bonding with hydrogens like this. Just see the structure. Here we can observe that in between there is a C single bond C, which is the overlap, and on each side of the carbon there are 3 CH single bonds. This is the structure of ethane. Here we can see that in the ground state, like as previous one, there are 4 electrons in 2 in 2s and 1 in 2p. In the excited state there are single electrons in 1s and 3p's. But while taking part in bonding we can observe that only 1 electron from S and 2 electrons from P are taking part, leaving behind 1 electron in the last P shell. So which is the unhybridized electron. So that is why we say that it is an sp2 orbital, because one s and 2p is taking part and one orbital is remaining unhybridized. This is the three orbitals of carbon which are taking part in hybridization. Now the last one which has not taken part in the hybridization, we will draw it in sideways manner. Similar drawing we will draw it in the second part. Now we will attach hydrogen atoms with the one which are hybridized orbitals in both the sides. And the last p orbital which is remaining, that will form pi bonds. This is the structure of ethene. Now we will go for type 3, which is sp hybridization. Let's see. This is the third type of hybridization, which is sp. Here in the ground state, like as the previous one, there are 2 electrons in 2s orbital and 2 electrons in 2p orbitals. In the excited state, there is 1 electron in each of the 4 orbitals. But while taking part in bond, only one s and out of 3 only one p orbital will take part in bonding. Remaining 2 orbitals will remain as unhybridized. That is why this type of hybridization is called sp hybridization. Now we are going to see a structure which involves carbon of sp hybridize. Here I have drawn 2 carbons which are forming one sigma bond at the center, that is C sigma bond C, and in both the ends there are C sigma bond H. Alright, now we are going to draw 2 unhybridized orbitals with a dotted line. As you can see that I have drawn 2 unhybridized orbitals with dotted line just to avoid confusion. So we can see that the unhybridized orbitals form pi bond and the hybrid orbitals form sigma bond. So in this structure we can easily say that there are 2 pi bonds and 2 sigma bonds. And this is the structure of CH triple bond CH. Okay, so in the very first video we have learnt about hybridizations of carbon, and now we are going to do some questions which some of them are taken from the NCERT book and some of them are taken from different textbooks. See, in every video I'll give you some questions to do at home and you will solve the answers and give the answers in the comment box. So let's move on. So we have written the question. Now I will tell you how to solve it part by part. See, we can understand from the question that there are 2 atoms there, carbon and hydrogen, and types of bond will be sigma sigma carbon and sigma CH2, and double bonds are there, that means pi CC bonds will be there. So we will write down the 3 types of bonds which we can get here. First one is your sigma CH bond, then is your sigma CC bond, and then is your pi CC bond. Now we will start our counting. Okay, so wherever hydrogens are there, that is your sigma bond, we'll just count it. See, 2H means 2 sigma bonds, 1H, 1 more, 3, here 2 more, 5, here 1 last, that means total CH sigma bonds are 6. Now we will count sigma CC bonds. This carbon with this carbon. We can number it also. Like 1, 2, 3, 4, 5. So between 1 and 2 there is 1 bond. 2 and 3 there is 1 bond. 3 and 4 there is 1 more. And 4 and 5 the last one. So how many sigma C bonds? 4. Done. Now left is pi CC bonds. So we'll count the number of double bonds in this structure. See, for this one there is 1 double bond. 2 bonds are there. One is sigma, another one is pi. So 1 pi we have got. Okay. In this one, 3 bonds are there. One is sigma, remaining 2 will be pi. So total 3 pi bonds. So this is how we have solved this question. Okay, we have already written the question. So here also we will do it in the same way. First we'll write sigma CC bond, sigma CH bond and pi CC bonds. And then we will start the counting. Sigma CC, sigma CH and pi CC. Let's count. 3 hydrogens, 3 sigma bonds. 1 hydrogen, 4 sigma bonds. 1 more, 5. Remaining 2, 6, 7. So 7 sigma bonds are there. Now CC bonds. You can do the numbering for this. 1 bond, second one, third one. So sigma CC, 3 bonds are there. Now we will count for pi. Only here we can see a double bond. 2 bonds are there. One is sigma, another one is pi. So pi bond only 1. Done. So it's very easy. So this kind of questions come to you in your examinations. So see, we can do it. So this is my compound and we have to identify that carbon is hybridized of which type, sp3, sp2 or sp. So we will draw the structure. So this is the structure and we can clearly see that there is no pi bonds here. So this will be hybridization type 1, that is sp3. This is our second question. So easily we will draw the structure. Okay. In this structure we can see that first carbon does not have any pi bond. That is, it has got 3 sigma bonds with hydrogen and 1 sigma bond with this carbon. So this carbon number 1 will be sp3. We can number the carbon and this one will be sp3. Clear? Okay, then we will go for the last one. Last one is also similar to that of the first one. It has got 3 sigma bonds and 1 sigma bond with carbon. And the second one, see, it has got 2 sigma bonds with carbon, 1 and carbon 3, 1 sigma bond with oxygen and 1 pi bond with oxygen. So 1 pi bond means sp2. So in this way we can solve this question. Now we will go for the last question. So this is our last question. See, this one has got 3 sigma bonds with hydrogen and 1 sigma bond with 1 more carbon. So the hybridization of this carbon will be sp3. Whereas this carbon has 1 sigma bond with this carbon and 1 sigma bond with nitrogen and 2 pi bonds with nitrogen. So hybridization having 2 unhybrid orbitals is the type 3 sp. So this carbon will be sp hybridized. So see, we have done few questions regarding today's topic, and one question I have given you as homework, which you can see in the screen, and also I'll give it in the description box. Do write the answer, solve it at home and write the answer in the comment box. So remaining part I'll continue in the next video, and general organic chemistry is a lengthy chapter. It will take time. I do not want to make one video more lengthy, rather I'll cut it into many parts, and part by part you can see it in different videos. Okay, if you like my effort, I have tried this for the first time, then do like, share and subscribe as much as you can. And also, there is always the chance of improvement. So if you want me to suggest any kind of improvement, do comment. I will take your comments positively. Thank you.